Domain 5 centers around identity and access management, with a focus on controlling physical and logical access to assets. It's essential to understand the mechanisms that govern access to applications, ensuring that only authorized individuals can interact with these systems. In this segment, we will discuss the best practices for managing access to various applications, a key aspect of maintaining an organization's security posture. This understanding is not only relevant for the CISSP exam, but also directly applicable in real-world security scenarios. I will guide you through the intricacies of implementing effective application access controls, covering both physical and logical elements. In this segment, we'll introduce the concept of application access control. It's imperative to grasp the importance of controlling access to applications, as it plays a significant role in bolstering your overall security posture. For those preparing for the CISSP exam, understanding access control not only enhances your exam readiness, but also equips you with practical skills applicable in the real world. We'll be focusing on both physical and logical controls to ensure a comprehensive understanding. From ensuring authorized user access to preventing unauthorized access, mastering these concepts is essential for effectively managing application security. Let's now explore the different types of application access controls that play a significant role in securing our systems. First, we have discretionary access control, DAC. In this model, permissions are determined and managed by the user. A common example is file permissions in Unix/Linux systems, where the file owner decides who can read, write, or execute the file. Next is mandatory access control, MAC. Unlike DAC, MAC is policy-based and enforced by the system rather than the user. An example of this is Security Enhanced Linux, SELinux, which implements stringent access policies that users and processes must adhere to. These access control mechanisms are fundamental to establishing a robust security framework for your applications, ensuring that only authorized users can interact with sensitive data and functions. On this slide, we are focusing on a practical example of discretionary access control in Unix/Linux. Specifically, we have a command that sets file permissions, chmod 755 example.txt. This command is used to dictate who can read, write, and execute the file named example.txt. Breaking it down, the owner of the file has permissions to read, write, and execute the file. The group associated with the file has permissions to read and execute. All other users also have permissions to read and execute. This example illustrates how individual users have the flexibility to control access to their files based on their discretion, which is a fundamental aspect of DAC. Let's examine an example of mandatory access control, MAC, using CLinux. When managing security using CLinux, we often start by checking its status with the sysstatus command. This command provides us with detailed information on whether CLinux is currently enabled, the policy being used, and the mode in which it is operating. To change the operational mode of CLinux, we use the setenforce command followed by a value of either 1 or 0. Setting setenforce to 1 enables enforcing mode, meaning all CLinux policies are actively enforced. Conversely, setting it to 0 switches CLinux to permissive mode, where policies are not enforced, but violations are logged for review. In summary, these commands help manage and enforce security policies at a more granular level compared to discretionary access control systems. Let's move on to discussing role-based access control, or RBAC. RBAC is a security mechanism where users are assigned specific roles, and these roles determine the permissions the users have. For instance, an HR role might be granted access to employee records but restricted from viewing financial data. This method simplifies administration by grouping permissions under roles rather than managing individual user permissions directly. This makes it easier to ensure that the right people have the appropriate access within an organization. Let's focus on implementing role-based access control, RBAC, using some example commands within MySQL. First, to create a role, you would use the following command: sql create role, role name. This command initializes a role within your MySQL database. Next, to assign specific privileges to this role, you use the grant command. For example, if you want to grant the select permission on a specific table to a role, you would do it like this: sql grant select on database.table to role name. By doing this, any user assigned to role name would have the defined access permissions, in this case, the ability to select data from the specified table. Understanding these commands helps you manage user permissions efficiently in a database environment, ensuring users only access data they're authorized to. Attribute-based access control, or ABAC, is a way to manage access to resources based on attributes associated with users and resources. These attributes can include details like the user's department, their clearance level, or any other relevant information. For example, in an organization, employees belonging to the HR department could be given access to human resources records. This is determined by their department attribute aligning with the access control policies set for HR records. ABAC offers a more granular and flexible approach to access management compared to other models. Here's a practical example of an attribute-based access control (ACC) policy defined in XML format. This XML document outlines a rule within a policy where access conditions are specified using user attributes. In this specific example, the rule is identified by the ID example rule. The critical part of the rule is the condition that evaluates the user's department attribute. The policy states that users whose department attribute has the value HR are allowed access. The XML structure looks like this: XML policy, rule ID, example rule, condition, attribute designator, attribute ID equals department, attribute value, HRU, condition, rule, policy. This format shows how you can control access by inspecting the attributes of a user, ensuring that only employees within the HR department can proceed according to this policy. By setting such rules, an organization can maintain precise and organized control over who can access different types of information and resources. Now, let's discuss the best practices for application access control. One fundamental principle to adhere to is the principle of least privilege. This principle advises that you only grant permissions that are absolutely necessary for users to perform their job functions. By limiting access rights, you reduce the risk of unauthorized access and potential breaches. Additionally, it is essential to regularly audit and review access rights. This means periodically checking and verifying that users have the appropriate level of access. Regular audits help you identify and rectify any discrepancies or over-permissioning, ensuring that your access control aligns with current policies and needs. Implementing these best practices creates a robust framework for managing application access, fortifying your systems against unauthorized access and protecting sensitive data. Let's move on to explore a real-world scenario where access control failure had significant consequences. In this instance, unauthorized access to sensitive data occurred due to misconfigured permissions. To address this issue effectively, rigorous access controls need to be implemented and continuously audited. Regular audits help to identify and correct any unintended permission settings before they can be exploited. In addition to manual checks, it's essential to employ automated tools for continuous monitoring, ensuring that any issues are detected and resolved promptly. By adhering to these strategies, organizations can prevent unauthorized access and protect their sensitive information from potential breaches. On this slide, we are focusing on practical tools for managing access control, with a particular emphasis on Active Directory (AD). Active Directory is instrumental in managing users and permissions within Windows environments. For example, you can add a new user with the command new AD user named John Doe. This efficiently creates a user account named John Doe. Additionally, to add a user to a group, you would use add AD group member identity admins-members John Doe. This command assigns John Doe to the admins group, thereby granting the relevant permissions associated with that group. Leveraging such commands makes managing access controls more streamlined and significantly reduces the risk of unauthorized access by ensuring correct permissions are applied to the right users. Let's summarize the key points we've discussed so far about access control management. We talked about the different types of access control, including discretionary access control, DAC, mandatory access control, MAC, role-based access control, RBAC, and attribute-based access control, ABAC. We explored how to implement these controls with practical tools like Active Directory, using specific commands to manage users and permissions, such as new AD user to create users and add AD group member to assign them to groups. Lastly, we touched on best practices, emphasizing the importance of adhering to the principle of least privilege, conducting regular audits, and using automated monitoring to ensure ongoing compliance and security. Now that we've covered the types of access control, DAC, MAC, RBAC, and ABAC, along with their implementation and best practices, let's move on to the next steps and further reading recommendations. First, it's important to practice using these access control methods in a lab environment. This hands-on experience will solidify your understanding and help you become more proficient. Second, review and understand the access control policies relevant to your environment. Knowing these policies inside and out will enable you to effectively apply and manage access controls. For further reading, I recommend the CISSP Official Study Guide for comprehensive insights into cybersecurity practices. Additionally, NIST SP 853 provides valuable information on security and privacy controls for federal information systems and organizations. These resources will deepen your knowledge and support your ongoing learning journey in access control and information security. On this slide, we have our references. These sources have been fundamental in shaping the concepts and practices discussed throughout this course. First, the CISSP Official Study Guide 8th edition offers comprehensive coverage of security principles and is a valuable resource for those pursuing CISSP certification. Next, the NIST Special Publication 853 provides detailed guidelines on security and privacy controls for federal information systems, which are widely applicable across various industries. We also have the CyLinux project documentation. CyLinux stands for Security Enhanced Linux, and this documentation delves into implementing security policies within Linux environments. Lastly, the Microsoft Active Directory documentation remains an essential guide to understanding access control and directory services within a Microsoft ecosystem. These references will deepen your understanding and provide additional insights into effective access control methods.